Hello friends, this is Priyanka. Today we are going to solve a problem on load division in between two generating units. In this video, we are going to calculate economic loading of two generating units as well as we are going to find out what is the loss in fuel cost per hour when the loads are equally shared in between two generating units. Now if we observe the given data, then incremental fuel cost for two generating units is given. So what is this incremental fuel cost? That is dFA by dPA, which is equal to 0.065 PA plus 25, and dFB by dPB, which is equal to 0.08 PB plus 20. Now in this case, A and B are the two generating units, and F is the fuel cost in rupees per hour as well as P is the power output in megawatt. Now for these given equations, I will read what is the given question. Find first the economic loading of two units when the total load supplied by the power plant is 160 megawatt. Second, the loss in fuel cost per hour if the load is equally shared by both the units. So this was the given question. We will move for the first question. We have to find out the economic loading of two units. So what is the condition that is required for the economic loading? So we know that this condition is dIA by dLA, which is equal to dIB by dLB, where A and B are the generating units, and here I is known as input and L is known as output. So this is the ratio and this is the condition required for the economic loading. Now if we observe this given data, then F is the fuel cost in rupees per hour is given and P is the power output in megawatt is given. So we can say that F, that is the fuel cost in rupees per hour, is known as input, and here P, that is the power output in megawatt, is known as output. So we can say that this is the ratio dFA by dPA is equal to dIA by dLA for the generating unit A, and this ratio dFB by dPB, that is equal to dIB by dLB. Now here one more condition is given, that is the total load supplied, and it is in megawatt. So here output is known as this P, use notation is P. So we can say that this is also output, that is PA plus PB, because total load supplied. So total load supplied by two generating units. So I will say that here the second condition is that PA plus PB is equal to 160 megawatt. And according to this condition, I will write the one equation. So dIA by dLA, nothing but this equation. So I will write therefore 0.065 PA plus 25 is equal to dIB by dLB, that is 0.08 PB plus 20. So we get here two equations in terms of PA and PB. So this is the equation number 1 and here is the equation number 2. Now we will solve these two equations and then we will get the value of PA and PB. So here I will say that what is the value of PA? So PA is equal to 160 minus PB, and I will put this value in equation number 2. So PA, instead of PA I will write 160 minus PB. So 0.065 160 minus PB plus 25 is equal to 0.08 PB plus 20. Now we will simplify this. 0.065 multiplied by 160, that is 10.4 minus 0.065 PB plus 25 is equal to 0.08 PB plus 20. Now we will take PB term on one side and all the other terms to the other side. So here I will take this term to the right hand side. So it will become 10.4 plus 25 and minus 20. So it is 15.4. So 15.4 is equal to this 0.08 plus 0.065. That is 0.145 PB. So PB is equal to, so we will say that 15.4 divided by 0.145. 106.2. So PB is equal to 106.206. Now this P is power output in megawatt. So we will give here the unit megawatt. Now from this we can find out PA. So PA is equal to 160 minus 106. So again 160 minus 106.206. So 53.79. Therefore PA is equal to 53.79 megawatt. We can say that for the minimum input, that is for the minimum fuel cost, we have to load unit A for 53.8 megawatt and unit B for 106.2 megawatt. So these are the economic loading between two generating units. Now we will move for the second question. So what is this question? If the load is equally shared, so load is equally shared in between two generating units, then we have to find out increase in the fuel cost. So increase in fuel cost, that means we have to find out what is this fuel cost. That is nothing but it is input, and which is given, that is in the form of DFA. So we have to find out. So we will move for the first unit, that is the for unit A. So for unit A, here is the equation DFA by DPA. So this is the equation in between input and output, which is equal to 0.065 PA plus 25. Now load is equally shared. That means out of this total 160 megawatt load, it is equally shared for unit A and unit B. So 160 by 2, 80 megawatt is given for unit A and remaining 80 megawatt given is for unit B. So load is given 80 megawatt and then we have to find out what is the increase in fuel cost. So we have to find out here difference. So remember, we should not start this that is from 0 to 80 megawatt loading, but here increase in fuel cost, this word is important. So for this increase in fuel cost, that means from minimum fuel cost, when economic loading is there, then what is the increase in fuel cost, that we have to find out. So we have to select the range in between minimum loading. For the minimum fuel cost, what is the amount of loading? So for this minimum fuel cost, here is the loading, that is 53.8 megawatt. And now when the loads are equally shared, the load is given as a 80 megawatt. So we have to select these two range. So in between these two range, if we take this two range and we will integrate this given equation, then we will get the increase in fuel cost. So I will write here. So here the increase in fuel cost is nothing but we have to take this DFA. So if I write this formula, DFA is equal to, if I transfer this DPA to the right hand side, then it will become in the bracket 0.065 PA plus 25 DPA. So I will take here the integration. So we will take here DFA is equal to integration, that is the increase in fuel cost is integration in between this economic loading 53.8 up to 80 megawatt, and I will write 0.065 PA plus 25 bracket complete DPA. So now we will integrate this. So how to take integration? So PA DPA, that means what? So we know that x dx, that is nothing but x square by 2. So in the same way I will write here PA square by 2. So I will solve this, that is 0.065 PA square by 2 plus 25 dPa, that is 25 PA. Now we have to give it's a range that is from 53.8 to 80. 53.8 to 80. Now how to solve this? So instead of PA, first we will put here 80 and then we will take minus sign and then we will put here 53.8. Therefore which is equal to, so I will solve here 0.065 PA square. So PA square, that means 80 square divided by 2 plus 25 into 80 minus. So minus we will put here 53.8. 0.065 into 53.8 square divided by 2 plus 25 into 53.8. Now we have to solve this. So if we simplify this bracket, then we will consider here the minus sign inside the bracket. So I will remove this bracket. So here is the minus sign and here also minus sign is there. And now we will solve this equation. Therefore the fuel cost for unit ADFA is equal to rupees 769 per hour. Now we have to take the same unit as given in the question. So F is the fuel cost in rupees per hour. So DFA is also equal to rupees 769 per hour. Now in the same way we will calculate this value for unit B. So for unit B, load is 80 megawatt and economic load, that is the load for minimum fuel cost. So load for minimum fuel cost is 106.2 megawatt. Now we have to find out when we share here the 80 megawatt load for unit B instead of 106.2 megawatt, then what is the change in the fuel cost. Now if we observe here this given equation, so DFB is equal to, so we have to transfer this DPB to the right hand side and we have to take the range in between this 106.2 to 80. Now here this is the load for minimum fuel cost. So we have to take this, that is the load from 106.2 to 80. We have to take integration in the bracket 0.08 PB plus 20 bracket complete here dPP. Now when we take integration, then 0.08 PB square by 2 plus 20 PB, and outside the square we have to write this limit, that is or range 106.2 to 80. Now in the same way we have to solve this. So first we will take here 80 instead of PB, that is 0.08 into 80 square by 2 plus 20 into 80 bracket complete minus, in the second bracket we have to put 106.2 instead of PB. So here is the bracket. So when we remove bracket, then we will get here inside the bracket minus sign. So for this term the answer is 256. For the second term it is 1600 minus here 451.30, and here if I remove bracket, here is also minus sign, so minus 2124. So when we solve this, we will get the answer minus 719.30. So here for this unit B, there is the decrease in fuel cost. So instead of 106.2 megawatt, if we load for 80 megawatt, then there is the decrease in input, or we can say decrease in the fuel cost. But we have to find out what is the net increase in the cost. So when we add these two costs, that is for DFA and this is the cost for DFB. This is for DFB. Then what is the net increase? That is 769 minus 719, which is equal to 50, and we have to give unit as same in the given question, that is rupees per hour. So here is the answer.